So in section 6.4, we're looking at complex fractions. And a complex fraction is a fraction that's written with a crazy numerator and crazy denominator, which means that you have like a fraction in the numerator of the fraction and a fraction in the denominator of the fraction. So you basically have like 4 fractions altogether if you're looking at it in 4 separate pieces. Because this big fraction here has a numerator that has a fraction and a denominator that has a fraction. This is called a complex fraction, and it looks like it's super scary, but here's how you rewrite them and solve them and simplify them. So if you ever have a fraction within a fraction, then what the easiest thing to do is rewrite it horizontally like this, like 5/14, as you can see written here, divided by 25/8. And then once you have it written like that, you can get rid of the crazy complex fraction look. Now it's just a division problem, which every division problem can be changed to a multiplication problem by keep changing and flipping, keeping the first fraction the same, flipping the division to multiplication, and then flipping this fraction upside down to its reciprocal, and then you can simplify. There's 2 ways to simplify fractions through multiplication. You can either multiply straight across, meaning you can multiply numerator times numerator. 5 times 8 is 40. And then denominator times denominator. 14 times 25 is 350. And then you can simplify this fraction. The easiest way to simplify is if you have a graphing calculator. In your calculator, you would just do 40 divided by 350. It'll give the decimal version for that. And then if you hit the math button, then enter, enter. It'll simplify it down to 4/35 for you. If you don't have a graphing calculator and you can't follow those steps, then what you would have to do at this point is simplify by dividing out the common factors in the numerator and denominator. The GCF is 10, so you can divide 40 by 10 and 350 by 10. That is where you get the 4/35 from. So that's one method. The other method in simplifying is cross-canceling. So if you remember, cross-canceling means that you can either look at the diagonals or you look at numerator versus denominator and try and pull out factors. There's no common factors between 5 and 14, but 5 and 25, you can both divide out a factor of 5. 5 divided by 5 is 1. 25 divided by 5 is 5. And then I can take a factor of 2 out of 14 and 8. 14 divided by 2 is 7. 8 divided by 2 is 4. And then from here, you can multiply the little numbers that are left. 1 times 4 is 4. 7 times 5 is 35. You get the same answer either way. It's just your preference in how you like to solve these problems. I think that the cross-canceling does work out to be the better method when we have polynomials, like in the next problem, so that you don't have to multiply them. You can just cross-cancel as you go. The next problem is x plus 2/3 divided by x minus 2/x. So you can see that it's rewritten horizontally. And then you keep the first fraction the same, flip the division to multiplication, and then the second one flips upside down. And then when that happens, you can look for cross-cancellation. In this case, nothing cancels out. X plus 2 is different than x minus 2, so you can't cancel anything out with that. So to simplify this and multiply it, all you would do is just take x plus 2 and multiply it by x, and then 3 and multiply it by x minus 2, and that would honestly just be your final answer. If you wanted to put the x in front of the x plus 2 so it kind of looks uniform, you can do that as well. But this would be your final answer. There's nothing you can do to simplify that. So, with the practice problems here, the first thing that you have to do to solve these problems is rewrite them horizontally. It'll change the whole look of the problem. It'll go from looking crazy to not that bad. So the first thing that you do is you rewrite the first fraction that's on the top. So this one right here, you're going to rewrite that first just as 4y to the 3rd power over 5x in parentheses squared. And then we're going to write a division sign, like an old school division sign. And then I'm going to write the second fraction exactly the way that it is, which is 2y in parentheses squared over 10x to the 3rd power. I don't suggest trying to do too many steps at once. I suggest first writing them out like this and then doing the the whole process with keep, change, flip, just so that you don't get yourself confused. Keep, change, flip means keep the first fraction the same. Change the division to multiplication, and flip the second fraction upside down. Now this problem is interesting because this is going to bring back some stuff that we haven't seen in a while with simplifying exponents. So in the denominators here and here, in order for us to be able to cancel anything out, we have to use some exponent rules that we haven't seen in a while. 5x squared, so if I just do a little bit of side work right here, 5x squared is the same thing as 5x times 5x, because whenever you take something and square it, you multiply that thing by itself twice. Same thing with the 2y squared. 2y squared is the same thing as 2y times 2y. So we can simplify that. We can also simplify it using the exponent rule, which is the product to a power rule, which says you take the outside exponent and you distribute it to everything on the inside, meaning that this turns into 5 squared times x squared. That's what this would end up being anyway. 5 times 5 is 25, 5 squared is 25, and x times x is x squared. So I can actually rewrite this as 4y to the third power over 25x squared times 10x to the third power over, same thing's going to happen here, 2y squared is 2 squared times y squared, which is 4y squared. It's important to do that first before you do any cancellations because you can't cancel anything out until all parentheses are gone. Now you can either multiply straight across, meaning you can multiply 4y to the third power times 10x to the third power, get that new answer, which is 40y to the third power times x to the third power, and then you can multiply 25 times 4 and x squared times y squared. It's up to you, or you can cross cancel. I think that cross canceling and looking at numerators and denominators does simplify the process a little bit. So that's what I'm going to do. I can see that this 4 can cancel out with this 4 since they're the same exact thing in the numerator and denominator. I have y to the third power, which is 3y's up top, y to the second power, which is 2y's in the bottom. So when you're canceling out the same variable, each pair, one top, one bottom, can cancel. So like 1y up here can cancel with 1y down here, 1y up here can cancel with 1y down here. I'm going to be left with 1y at the top. I can also get that from subtracting 3 minus 2, and 3 minus 2 leaves you with y to the first power, and it'll be left here at the top, so we can completely cross this bottom one off, and this one is just going to turn into y to the first power, or just like a plain y. Same type of thing's going to happen with the x's. I have x to the third power, which is 3x's up top, x to the second power, which is x squared at the bottom. One pair of x's up top will cancel with one at the bottom. So for here, I'm going to be left with only one x at the top. So this x to the third power will end up just being x to the first power. And then these x's down here go away completely. And then looking more so at the numbers again, if I wanted to, I could cross cancel still, but I'm kind of losing track of everything that I'm doing. I can also pull out a factor of 5 here and here. If I do that, 10 divided by 5 is 2, 25 divided by 5 is 5. So everything that I have left, cross canceling, the word gets a little bit confusing. I have one y up top, a 2 up top, and one x up top, and then on the bottom, the only thing I have left is 5. So this would end up being 2xy over 5, and that would be fully simplified without having to do any simplification. And I got that by multiplying everything that's left because this is a multiplication problem. But you did not have to necessarily do that. If you wanted to take it from this up here, you could also just take everything and multiply it and then simplify in the end. It's up to you and the process that makes the most sense to you. If you like cross-canceling, then this is the way to go. It just gets a little bit confusing along the way. If you don't like cross canceling and you have no idea what I just did, then let me show you this other method, which is just multiply, deal with it, and then simplify. Multiply and then deal with it, we would have here 25, was this x squared? Yeah, x squared, and then we would have 4y squared. Multiply and deal with it would mean multiply everything on the top. 4 times 10 is 40. Y to the third power at the top, x to the third power at the bottom, over 25 times 4 is 100, and x squared times y squared. Once you do that, then you can cancel out everything that you can and simplify. 40 over 100 will simplify to be 2 over 5 in the end, so I can just simplify that now, 2 over 5. And y to the third power with y to the second power, I'm going to be left with 1y at the top here. X to the third power over x squared, I'm going to be left with 1x up here. So same answer, looks a little bit different. The process looks different, but you should get the same thing. All right, for the next problem, first thing you should do is rewrite it horizontally. So let's take a minute and let's rewrite x plus 1 over x plus 2 divided by x plus 1 over x plus 5. Rewrite it horizontally as a division problem. So take 1 minute to do that. Okay, once you rewrite it, you should see something like this. X plus 1 over x plus 2 divided by x plus 1 over x plus 5. I suggest taking the time to do that and not doing too many steps at once. Then to solve this, you would keep, change, and flip. And then once you do that, it should be set up most of the time for you to cross cancel. If you have the same thing on the top as you do in the bottom, they will cancel out. These are considered to be in factored form, so I can cancel out one of these x plus 1s up here with one down here, and I'm left with just x plus 5 over x plus 2. That would be the final answer. And then, of course, these are going to get a little bit more difficult if you ever need to simplify by factoring. So letter C, we have here this divided by this. So the first thing I'm going to do is rewrite this as a horizontal problem of x squared plus 4x plus 3 over x minus 2 divided by 2x plus 6. So the second problem isn't already in fraction form. So when I go to keep, change, flip it, you're going to need to have the idea that it is a fraction. You can make it into one by putting it over 1 like that. So then when I rewrite it, it'll be x squared plus 4x plus 3 over x minus 2 times, flip it around, 1 over 2x plus 6. Now, if we are going to multiply this and simplify, we would first want to factor everything so that it's in factored form, knowing that when things are in factored form, you can simplify them if you have the same thing on the top as you do on the bottom. Thankfully, all of the things that can be factored pretty quickly and easily. X squared plus 4x plus 3. What multiplies to be 3 and adds to be 4? Well, that would be x plus 1 times x plus 3. Since 1 times 3 is 3 and 1 plus 3 is 4. X minus 2 is already factored. And 2x plus 6, all I can do is take a factor of 2 out, and I'm left with x plus 3. Once you have everything in its factored form, then the next thing you should do is cancel out anything that's in the top and bottom. The only things that can cancel out would be this pair of x plus 3's. And then whatever you're left with, you multiply and keep where it's at. So x plus 1 times 1 is just x plus 1. minus 2 times 2. I'm just going to write the 2 up front. 2 times x minus 2. That would be the final answer for that problem. All right, so hopefully you're understanding this process. The first thing you should do is rewrite it horizontally, so it's a division problem horizontally like we've been seeing in section 6.2. And then keep, change, flip to turn it into a multiplication problem. Factor everything that can be factored. Cancel out anything that's the same in the top and bottom. And whatever you're left with, multiply, and that should be simplified at that point. On the next page, there's 4 practice problems that I would like you guys to try. So go ahead and take some time to do those, and we'll go over these before the end of class today.